Welcome all of you to another video of Animaths. This is going to be my first video in physics today. Okay, I'm starting with physics videos today. Okay, so I'm going to start with the chapter light. Now light for ICSE students, light starts in 9th standard. For CBSE it is in 10th. So in 9th standard ICSE students do reflection. So of course in the lower classes you do light in a as an introduction. They take it up as an introduction, but in details the light is taken only from 9th and in 9th standard. Okay, so I'm going to start with the chapter from scratch, assuming that you haven't done any introduction earlier. So this is going to be starting from the very basics of the chapter. So if you listen clearly, you'll be able to understand the entire chapter very clearly, and you'll also see how easy it is. Okay, so let us see what the chapter is. Now, what is light? If I ask you this question, what is light? Light is nothing but a form of energy. Okay, light is a form of energy. Okay, you have lots of other forms of energy too. You have sound is a form of energy, electricity is a form of energy, even there are so many, heat is also a form of energy. Now these forms of energy, we can experience them, we can feel them, we can utilize them, but we cannot touch them. Okay, so that is, we cannot hold them. So that is a form of energy. Light is a form of energy. So now let us see how exactly, now all of you know light helps us to see. That is, that the room is dark and suddenly you go and when you go and switch on the light, you start seeing everything in the room. Now why is it that only after switching on the light we see everything in the room? How does this seeing, the entire system of seeing something happen with the help of light? Okay, now assuming you are going in a car in a very dark night, you are passing through a very dark road which does not have road lights, and your car headlight is the only light. Okay, now if you are sitting in the front seat, you suddenly see a cat in front of the car. Now you will see the cat only in the area where the headlight is falling. Okay, you didn't see the cat here, neither will you be able to see the cat here. You will be seeing the cat only here. Okay, so that is called, that is why are you seeing the cat only here? The reason is light rays are falling on the cat and reflecting back to your eye. That wasn't happening here because no light was falling in it, so nothing was reflecting back. So you get to see the object only when light falls on it and it comes back to your eyes. Then you are able to see the cat on the road. Not just this, anything in your room. If your room is lighted, you are seeing the chairs, you are seeing the tables, you are seeing everything in the room. That is all because of reflected light. We see everything due to reflected light, and that is why without light we cannot see anything at night, because there is no natural light, and we don't see anything at night because unless you switch on an artificial light. Okay, so now if I talk about whenever light falls on any object, there are three things which happen whenever light falls on any object. One is reflection, which we just talked about. Okay, one is reflection, one is refraction, okay, and one is absorption. You might not have heard of the third one. Now reflection is light is falling on a body, and light falls on a body and then it goes back to the same medium. That is what we are going to do in detail now. Diffraction is when light is falling on from one medium and it is passing through another medium. That can be water, it can be oil, it can be glass. So when light goes from one medium to the other, it is called refraction. And the third one is light gets absorbed in the medium. So if the body is transparent, then only refraction can happen. If the body is opaque, then reflection can happen. But then absorption happens here also. Absorption happens in opaque body also. Absorption happens in this body also, in transparent body also absorb, and remember even reflection happens in transparent body. Okay, so light is falling on it and partially getting reflected. That is why we are able to see this transparent body. Okay, it passes through it, and then when it can come back to the same medium. So that is called refraction. So refraction can happen only for transparent bodies, but transparent bodies also reflect light and also absorb light. The third one is absorption. Now you will see that if you have kept a very a metallic plate on the terrace in an afternoon, you will see that in a very sunny afternoon, of course, you will see that after some time it has got warm. Okay, the reason is it has absorbed a lot of light energy and it has changed it to heat energy due to the law of conservation of energy. Okay, so as I said, three things happen when light falls on any body. Either it can reflect, it can refract, or it can absorption. Okay, so or it can be absorbed. Okay, so these are the three things that happens when light falls on any body. That can happen when light falls on any body. Okay, now let me talk a little bit about the laws of reflection. Laws of reflection. Okay, now this, when they ask you for the laws of reflection, you should give them the complete in the textbook word. You should not write these things in your own words. Definitions should be in the textbook word. Laws, principles, they should all be exact textbook words. Okay, first law. Angle of incidence is equal to the angle of reflection. Okay, angle of incidence is equal to the angle of reflection. I'll talk about what angle of incidence and what angle of reflection is. The next thing is the incident ray, the reflected ray, and the normal all lie on the same plane at the point of incidence. Okay, all lie in the same plane at the point of incidence. So these are the two rules. Okay, first thing, angle of incidence is equal to angle of reflection. Now if I have, this is supposing the plane, here is the normal. Okay, that is the normal. There's the 90-degree line on the plane that we call the normal. Okay, so if we have a plane over here, this is the normal, that is the 90-degree line on it. Now one plane can have many normals, it can have many normals, okay, at different points. So there's no line actually, it's an imaginary line. So we imagine a 90-degree line over here which is called the normal, it's not a ray. Now this is the incident ray, the ray which falls at the point of incidence. Let's say P is the point of incidence. Okay, that is the incident ray and this is the reflected ray. This becomes the angle of incidence, this is the angle of reflection. Okay, the angle of incidence is the angle that the incident ray makes with the normal. The angle of reflection is the angle the reflected ray makes with the normal. According to law of reflection, I has to be equal to R. Okay, and the second thing is the incident ray, the reflected ray and the normal all lie in the same plane. This is where people go wrong because they somehow don't understand the usefulness of this. Okay, all lie in the same plane at the point of incidence. Now if supposing I have three things over here, the middle one is the normal, one of them is the reflected ray and one of them is the incident ray. Now these are my three rays. Now if I can make a paper pass through all of them. Through means if I hold a paper like this, if all the three of them lie on this, all three of them lie on this paper, then they are on the same plane. Okay. Now you might think they will always be on the same plane. No, they will not always be in the same plane. See, just see. You see, I am throwing one out of line. Okay. Now if you hold a paper here, only these two are in the same plane, but the middle one is outside, so it's not in the same plane. Similarly, I can even move another one out of the same plane. So plane is there for these two, but for the third one, plane is not there. Okay. So, but remember one thing, I can still have, even if they are not in the same plane, I can still have the angle of incidence is equal to the angle of reflection. That is why for them they have to be on the same plane as well. Okay, according to laws of reflection. Then, now what are the types of reflection? Okay, the one type is the regular reflection. Another is irregular reflection. These are the two types of reflection. Okay. Now if I have, supposing I have a polished surface here. Remember, any polished and very smooth surface is called a mirror in, okay, this is a polished surface. Okay, so it's called a mirror in physics. Here I have a rough surface. Now this roughness might not be visible in the naked eye, okay, but under the microscope you will see these lines. Okay, so this is a rough surface. This can be the it can be the paper of your notebook, it can be the cover of your textbook, it can be a tabletop which otherwise looks very much polished, but according to physics it can still be a rough surface. Okay, here this polished surface should not have even these microscopic roughness. So this is a rough surface. So actually, if you remember, whenever you have bought a steel plate from the market, just after it is brought home, you can actually see your face in it very clearly, just like a mirror. It just works like a mirror, right? It just works like a mirror. You see your face in it. But then after it has been scrubbed for some few days, after that, when you have scrubbed it for few days, you cannot see your face that clearly anymore. The reason is, it has got, if you see carefully, you will see it has thin lines in it due to the scrubbing, and that has made it actually like this. Okay, so it is a rough surface now. So it ceases to be a mirror. Here it was a mirror when it was just bought. After 1 month it has become like this. Okay, so according to physics, even a steel plate can be a mirror. A steel plate, if it is not rough, is a mirror. Okay, mirror necessarily does not have to be made out of glass that we generally think. Okay, we generally think mirror is a glass object. Now here let me draw few incident rays. See, here I am drawing few incident rays which are parallel to one another, and then the reflected rays will go like this. These are my reflected rays. Okay, these are my reflected rays. So now if you note that these incident rays are all parallel to one another, and even the reflected rays are all parallel to one another. This is called regular reflection. Why? Because if I draw a normal here, okay, now this is regular reflection. Why are they regular? Because the incident rays were parallel and the reflected rays are also parallel. So this kind of reflection is parallel. Okay, is regular. Now if I draw a normal here, angle of incidence will be equal to angle of reflection for each one of them according to the laws of reflection. Angle of incidence will be equal to angle of reflection. Okay. Now if I take the rough surface, let me draw few incident rays again. Okay, let me draw few. Again the rays are, what I am drawing is again parallel. Okay, so I have 4 incident rays which are parallel to one another. Okay, and now I'll draw the reflected rays for these. So note. Okay. So these are the reflected rays. Okay, but what do you see? They are no longer parallel. The reason is this surface is rough. Now remember one thing, here they are following the laws of reflection. Even here, that is I is equal to R, so we say they are following the laws of reflection. Here also they are following the laws of reflection. Even here they are following the laws of reflection, but we feel that they are not following the laws of reflection because of all this chaos over here. So actually what you have to understand, that the normal is drawn at the perpendicular to the tangent at on these curves. Okay, tangent at the point of incidence. So if I have, see, this is the normal at this point, then I is equal to R only. Here also we draw tangent like this and then we draw the normal, then again I is equal to R. Here also we make a tangent at the point of incidence. So at the point of incidence the normal itself is tilted. Okay, the normal itself is tilted, and therefore we have the I is equal to R is followed in all the cases. The only thing is the reflected rays are not parallel. So don't get the impression that here laws of reflection is followed and here laws of reflection is not followed in a rough surface. Okay, so that is what regular and irregular reflection is all about. Now let us talk a little bit about images. One type of image is real image, another is virtual image. Now what are real images and what are virtual images? Real images are images which are formed by actual intersection. You can get the differences in any textbook by actual intersection. Virtual images are images which are formed by when the rays seem to meet, the rays seem to intersect or the rays seem to meet, then we have virtual, and real is by actual intersection. Okay, you need a screen for real images. To see a real image you need a screen. What they mean by a screen is it's either a piece of white cloth, big one, or it can even be a wall. Even a wall can work like a screen. Okay, and virtual images are, they don't need a screen. If I go back to this, they seem to meet. Okay, when you stand in front of the mirror, you are actually seeing a virtual image, because do you think any ray, if the mirror is here, you are standing here, do you think rays can enter the mirror? Rays cannot enter the mirror, because what is a mirror? A mirror is actually a transparent piece which has been made opaque by the silvering. Look behind a mirror and you'll see a red kind of paint which is called a silvering. So it has been made opaque. So as long as it is opaque, no ray can enter. So if it is opaque, light does not enter, and so it is a virtual. So what you are seeing is, it's looking as if light is traveling inside the mirror and forming the image, but it is not so. It is actually a virtual image. That is, you get the illusion that light is coming from inside the mirror. Okay, so we'll talk more about real and virtual image. Actually, this concept is what is required for the entire of 9th and 10th standard light. All the time you have to have your idea of real and virtual image very much correct. So as we proceed with light, you will understand how by actual intersection real images are formed. Okay. real images are always inverted. You'll see that also why it is inverted. That is, if I get the image of this in real images, it will be like this, okay, and virtual images are always erect. That is, they will be straight like you see yourself in a mirror, okay. So these are the basic differences between real and virtual images. So that was a very brief introduction to the chapter light. We'll stop here today and we'll take up light in the very next video. So these light is a big chapter, so you'll see, please check for the videos as light part 1, part 2, part 3, like this it will be named, okay, and all the other parts of light you'll always find in the description box of the video, okay. So you can just go through the videos one after the other to make a very clear concept, okay. So that is it for today. If you have liked the video, do not forget to like, share and subscribe. Thanks all of you for watching the video.